Hi, everybody. Welcome to my channel, Numbers with Nora. In this video, we are going to be doing geometry. We're going to be doing continuing chapter 4, and we're doing section 4.2, applying congruence and triangles. All right. The book that I'm following is Larson Geometry. Again, I will sit there and put the link to that book in the comments so you can follow along with that book. But also, if you're just using your regular geometry book that your teacher gave you for class, you can follow along with that as well. All right. So let's start. All right, so for this one, the objective of 4.2 is you will identify congruent figures. And first, let's sit there and define what congruent figures are. So congruent figures are figures that have the same shape and size. Okay. So the figures that have the same shape and size. As for corresponding parts, these are going to be parts that match between, excuse me. They're going to be parts that match between two congruent triangles. Okay, and we're going to be using both of these definitions pretty hard in this chapter. Usually to prove congruent triangles, you're going to have to sit there and show that they're congruent figures. And then also congruent figures leads into corresponding parts, but we'll get more into that later. All right. So let's go into our key concept right here. Like I was saying, corresponding angles and corresponding sides are two things that you want to show when you're showing that two triangles are congruent. All right. And then also notice the naming convention on these as well. So angle A and angle F are going to be congruent. They both are annotated with just that one arc, which means they are congruent. B and E are congruent, and then D and C are congruent because they have three arcs. Now, when it comes to our sides, order does matter, okay? So when I sit there and say side A and B congruent to side F and E, that order of F to E and A to B does matter. And then again, AC, FD are congruent, BC and ED are congruent as well. Okay. So let's jump into our first example. Let's zoom in so we can just concentrate on this one. And I believe this one we're just listing our angles that are congruent and our sides that are congruent. So right here it says write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. All right, so first let's put down our corresponding angles. Again, our angles are kind of easy to match. Our K and our S are going to be congruent. They both have the same annotation, so angle K. And then congruence, we just write the equal sign with the little squiggly on top. That means congruence. Angle S. Okay. And then so on and so forth. Angle L and angle R. Angle L. Congruent to angle R. And then last but not least, we have angle J with the three arcs annotation, congruent to angle T. So those are all of our angles that are corresponding. So now let's go into our corresponding sides, okay? So again, we want to label our sides because in order, so order matters. So let's start with J to K. So I'm going to put side JK. All right, JK, and then we put this on top to indicate it's a side that we're talking about, and that's going to be congruent to. Now I started with the side that has three arcs, and then went to the side that has one. So the same thing with here. So we know it's congruent to TS because I started with the one with three arcs and I ended with the one with one arc. Start with T, I'm going to end with S. Okay, and that's going to be the corresponding one. Some people make that mistake of not putting it in order. And then let's go to our one with the 2 tally marks. So I have L to K. L to K. And my corresponding side from L to K, L had the 2 arcs. So I start with the one that had the 2 arcs, is corresponding to R to S. Okay, to S. And then last but not least, our one with our 3 tally marks. I'm going to start from J to L. J to L. And again, J is the one that has the 3 arc markings for my angle. So then when I do this, I'm not going to put R to T. I'm going to put T to R, okay? T to R. All right, and those are all my corresponding angles and corresponding sides. And when we do our proofs, where we'll sit there and see, we're going to have to sit there and show that they're all corresponding angles and all corresponding sides in order to show congruency. So let's continue to another example. For this one, we're going to use properties of congruent figures, okay, to find x and y. So A, we want to find x. So notice up here, they do give us the order that we have to go in. So this goes from D, E, F, G. And this one goes from S, P, Q, R, okay? So an example, D is a corresponding angle with S. E is a corresponding angle with P, F is a corresponding angle with Q, and G is a corresponding angle with R, okay? I know that because that's the order that they gave us, so we have to go in the order that they gave us. All right, so let's go ahead and find this side first. I'll go ahead and mark it. So this side, again, is going to be QR. That means the corresponding side for the other one is going to be FG. So it's going to be this side. Corresponding sides are congruent. So how I set up that equation is I do 2x minus 4 equal to 12. Now I just use basic algebra from algebra 1 to solve our linear equation. I just have 2x, 12 adding 4, 12, 13, 14, 15, 16. Divide the 2 to get rid of the coefficient of the x. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. That's going to be 8. Okay, our x is going to equal 8. And we're going to use the same concept for our y, okay? Except this time we're not looking at sides, we're looking at angles. So the corresponding angle to this Q right here, again, I can go over here and see what my spot is for here. My third letter is going to be F, so those ones correspond. So F and Q correspond. Since they're corresponding angles, they are equal. So then I set up my equation, 6y. Oops, just a second. Okay. So I set up my corresponding equation, 6y plus x equals 68. But again, we already found x, so we use substitution. So I have 6y plus 8 because we solved and found our x, and our x was 8. That equals 68. And again, we're just solving a simple linear equation. We subtract 8 from both sides. So then I get 6y equals 60. And then I divide both sides by the coefficient of 6. So then I get y equals 10. Okay. And that's how we're going to sit there and do example 2. Right. Again, if you have any questions on any of these examples that I'm doing, go ahead and write them in the comments and I will happily answer them. All right. So example number 3, this one we're going to show that figures are congruent. All right. It's kind of like a word problem. If you divide the wall into orange and blue sections along JK, so along here, we're dividing the wall. Okay. Will the sections of the wall be the same size and shape? So remember, to sit there and show same size and same shape, we need to show that all of my sides are corresponding and then all of my angles are corresponding. Okay. So let's go ahead and start with angles, I believe. Let's start with angles. Okay. So let's see what angles correspond. So looking at this, I can sit there and say that A and C are corresponding angles because they both are equal to 90 degrees. 90-degree angles are congruent. So I could say A is congruent to B. Another one here, 90-degree angles right here. I can also say that D is congruent to B, or D is congruent to B. Sorry, I meant A and C on this one. My apologies. A and C, because they're the shorter sides. There we go. That looks better. And then angle D, congruent to angle B. Okay. And now let's see some more corresponding angles. Now they do sit there and show, since these these are parallel lines. Okay. And what we learned from chapter 3 is we have a transversal cutting our parallel lines. Then we could sit there and see our angle relationships. So if we look at this to be our transversal and A and B and D and C to be our parallel lines, then that means 2 and 3 are going to be congruent because of alternate interior angles. And then also 1 and 4 are going to be congruent because of alternate interior angles, okay? So I'll put angle 1 congruent to angle 2 and angle 1, sorry. Angle 2 congruent to angle 3. Let me pay attention to what I'm doing. My apologies. Angle 2 congruent to angle 3. That's better. And then angle 1 congruent to angle 4. And this is by alternative interior angles theorem. And that's coming back from chapter 3. Okay, I'm just going to put the abbreviation for it, alternate interior angles. Okay. All right, so we have these being congruent because they're 90-degree angles, and then we have angle 3 and angle 2 being congruent, and angle 1 and 4 being congruent because of alternate interior angles. That covers all of our angles, so we sat there and got our angles down. Now let's do our sides. Let's sit there and look at our corresponding sides, right? So for sides, they do sit there and give us some annotations, which can sit there and help us out a lot. So let me get rid of the ones that I used to sit there and find our angles. So there for this one, A and J is congruent to K and C. That's just because they both have that one tick mark. So they gave us that those are congruent. So A and J congruent to C and K. Okay. Then another one, these tick marks, they give us those. So J and B congruent to K and D. K and D. All right. And then we also have A and D congruent to C and B. Those are all given. Now, the last one we want to show that are congruent is this J and K. All right. And to prove that that's congruent to one another is notice that both these shapes share that side. So that's actually going to be called the reflexive property, okay? Because it sits there and belongs to this figure, and it also belongs to the other figure on the right. So we call that transitive property. So let's state that. We say that JB is congruent to B and J. Okay. And so that means that if you divide the wall into orange and blue sections along JK, oops, that's JK, my apologies. JK. JK. And then KJ. Okay. Been doing math all day. That's what happens when you do math all day. All right. So JK is congruent to KJ. Okay. So since I sat there and proved that I have corresponding angles in all corresponding sides, that means that if the wall is divided into orange and blue sections along JK, will the sections of the wall be the same size and shape? Yes, it will be the same size and shape. Okay. And I believe we have a theorem that's very important. This will pop up again. For this theorem, it's called the third angles theorem. Basically, it's stating that if I have two triangles and they share two angles that are congruent, then that means automatically that that other angle that's not marked, those are going to be congruent between the two triangles. All right. And we will see this one again throughout chapter 4. All right, so let's do 2 more examples. For this one, find the measure of BDC. So BDC, finding this whole one. All right, so I always think it's better like when you sit there and pull these apart and sit there and kind of see what they look like when they're pulled apart. All right, so let's sit there and do this. So they're not composite triangles. All right, we'll have A, C, and D. And then we'll have B, D, and C. All right, and they already have markings for us. All right, so they say that A and B are congruent, so these both equal 45 degrees. Cool. And then they also have that this one, C, and this D are congruent. All right, so just from our theorem, since we have those, that means that this has to be congruent with this triangle by that theorem that we just looked at. The third angle triangle. Okay, that means those have to be congruent. So let's go ahead and find them. So what we do know about triangles is that their sum is supposed to add to 180 degrees. Okay. So we can sit there and use either triangle to sit there and figure that out. How we would set up that equation is we do all my angles in my triangle equal to 180, so 45 plus 30. I'm just going to label our unknown angle as X. Okay. And that's equal to 180. All right, and then we keep on solving this simple linear equation, 45 plus 30, 40, 50, 60, 75 plus X equals 180. Subtract 75 from both sides. I believe that's going to give you 105. So x is going to give you 105, which means that that angle that they wanted us to find is going to be equal to 105 degrees. Right? And that's how we solve that one. All right. Any questions on 4? Just put in the comments. Now, I believe this is going to be a proof, and we do need practices with proofs, so proofs are always good. So this one, we're going to prove that triangles are congruent. All right. And so to do this one, let me see. Proof that triangles are congruent. Yep. So for this one, let's see our given. So they give us that AB and CB are congruent, and also DC, they have our markings down. DC and AB are congruent, and then also that these angles that they mark down are congruent. That's all given. They want us to prove that these two triangles, ACD and then also CAB, are congruent. Okay, so to do that, they have a little plan for us. All right, so first you always write down your given, just for time's sake. You would write down all this here for your given. All right, then write down given. Second step, we want to notice that we want to sit there and prove all of our corresponding angles and all of our corresponding sides. So let's start with proving all of our corresponding sides, okay? So it was already given that this side and this side are congruent, and this side and this side are congruent. So I need to sit there and show also that this side is congruent as well. So that way that we can sit there and say they're congruent, all my corresponding sides are there. So for that one, remember, since it's sharing a side, I can say AC congruent to CA, and remember that's by reflexive. And we'll just use that all the time when we sit there and see that two of our similar shapes are sharing a side. And that's reflexive. All right. Reflexive. And I believe that property we did see in chapter 3. Reflexive property. All right, so that's it for our sides. Now all our sides are congruent. Now we have to worry about the angles. So they give us that A and C are good, and then we have these angles are good. But then how can I sit there and show that B and angle D are also congruent, okay? Now remember our theorem up here, what we said about the third angles theorem. If two of my angles are congruent, that means the other leftover angles of the two figures are also congruent. So we could sit there and argue that angle D congruent to angle B. And this is by the third angles theorem. All right. Third angles theorem. I'll just put angles theorem. And then our last step is we just state what we proved. So we just go triangle ACD. Sorry, that's a little sloppy. Congruent to triangle. My pen is messing up today. Triangle CAD or CAB. Okay. And this is by the corresponding parts. Corresponding parts of triangles. All right, and that finishes that proof. All right, so those are the things that we have to show. We just have to show that our corresponding sides are congruent and then our corresponding angles are congruent. And if we can show that, then it means the two figures are similar or are congruent. All right, so then we have another theorem right here. These ones, I guess you can like keep handy in your notebook. We're not really going to go in depth with these, but these are just properties of congruence with triangles in just period. So having these in handy are good. You can read over them on your own time and see, but like we're not going to be really getting really into it in chapter 4, but they're always good to know. All right. All right, so also if you have any homework questions or would like further tutoring, please subscribe or leave me a message in the comment section below. And then also, if you leave like a homework problem in the comments too, I can also respond back to that and show you step by step how I get the answer. All right, thank you guys.